Hi everyone, I'm Nico Girnitz and I'd like to introduce MLOX, open source MLOps for the rest of us. MLOX is a control plane for self-hosted AI infrastructure. Today, even large organizations struggle with MLOps, and for individuals or small teams, the gap is even bigger. You rely on managed cloud platforms, which are powerful but complex, expensive, and often lead to vendor lock-in. Or you try to build your own stack, which requires significant DevOps expertise and a lot of glue code. In practice, many teams face the same constraints. They don't have the time to operate complex cloud setups, they don't want to commit to a single hyperscaler or multiple ones, and they lack the resources to build and maintain a full system from scratch. MLOX is designed exactly for this setting. The core idea is simple: make it possible to run a complete, secure and observable ML system on your own infrastructure without needing a dedicated DevOps team. So the problem is, when building machine learning systems, you typically deal with three layers. First, infrastructure: servers, runtimes, security. Second, services: databases, pipelines, tracking, registries, serving. And third, integration: configs, secrets, dependencies, and monitoring. Each of these layers is already complex on its own. And while there are many tools available, most of them focus on just one piece of the puzzle. So what happens in practice is that teams end up stitching together everything themselves, often with fragile scripts and ad hoc setups, and that leads to a key observation. Most tools solve one piece, but the user actually needs the whole system. So what MLOX does? MLOX addresses this by structuring the problem into three parts. First, servers. You define and manage infrastructure. Choose a backend like Docker, Kubernetes, or native execution and monitor it. Second, services. You install and manage components like MLflow, Airflow, or ML Server, including configuration and secrets. And third, wiring. This is where MLOX becomes interesting. It understands services and how they connect, resolves dependencies, and links everything together. So instead of manually integrating components, you work at the level of systems, not individual tools. Right now, lifecycle management is intentionally simple, mostly add and remove, because the focus is on reducing complexity, not adding more layers. The architecture follows a simple but important idea. Users can interact with MLOX through the CLI, UI, or TUI. So in practice, they don't need to write configuration files themselves. Under the hood, these interactions are translated into a structured configuration, including servers, services, and their relationships. So a session loads this configuration together with state and secrets and builds an internal infrastructure graph. This graph represents how all components are connected. From there, different backends, such as Docker, Kubernetes, or native execution, translate this into actual deployment actions. So MLOX acts as a kind of a middle layer, not adding complexity, but absorbing it and exposing a simpler interface. Another important aspect is extensibility. Through a system, a plugin system, new services, integrations, or even backends can be added without changing the core system. So MLOX currently supports multiple backends. Docker is the most complete and stable today. Most services run on Docker. Kubernetes is already supported and being extended with more services. There's also a native mode for lightweight setups and a connector backend for hybrid or external integrations. On top of that, the system is structured in layers: infrastructure, services, integrations, and plugins. This makes it possible to grow the ecosystem over time without turning the core idea into a monolith. So the goal is not to build everything into MLOX, but to provide a structured way to integrate everything else. Let me give you a very simple example. From the CLI, you can list all registered models. with MLOX model list. Then you can deploy a specific model version to a target server with a single command, MLOX model deploy, then the version and the registry and the model, and the target server. What happens under the hood is more interesting. MLOX automatically connects the model registry, retrieves artifacts, configures the serving layer, for example via ML server, and ensures that everything is deployed securely. So instead of manually wiring together multiple components, you define what you want and MLOX handles how it connects. So why is this useful? Well, from early usage and feedback, a few patterns emerged. First, integration is the real bottleneck, not individual tools. Second, simplicity wins, especially for small teams. Third, transparency matters. People want to understand what is happening. And fourth, self-hosting becomes viable once complexity is reduced. So in terms of positioning, MLOps sits somewhere between fragile custom-built pipelines and large cloud-native MLOps platforms. It tries to combine the flexibility of the first with some of the structure of the second. So, looking ahead, there are a few main directions. First, security. Better networking, firewall integration, and more advanced certificate handling. Second, features and platform, especially deeper Kubernetes support and improved service integrations. And third, simplicity. Lighter alternatives to existing tools, smaller default setups, and potentially separating monitoring into its own application. The guiding principle here is important. Not just more features, but more secure and more minimal. So as a takeaway, to summarize, MLOps abstracts servers, services, and their wiring into a single consistent system. It is open source, self-hosted, and extensible, and designed for teams that need complete systems, not isolated tools. And since this is an early stage project, we are actively looking for contributors, collaborators, and feedback, and also open partnerships and funding discussions. If this resonates with you, I'd be very happy to connect. Thank you.